So I'm going to give a LeetCode contest today. It's LeetCode Biweekly. It's my first LeetCode Biweekly. So let's see how will I do. I hope I can solve all four problems, or at least three in the worst case. I think I can surely solve three. I want to solve four. It's 59 seconds, guys. Let me share screen. Mm-mm-mm. Let me open these things too. What is date today? Sep 27. But then I don't make a folder. I want to write golden rules. I just want to add golden rules. That's it. Because these are important to problem solving. See them well. I just add them. Should I grow my hair or should I cut it off? Comment below. We should be quick. We should solve all problems. We should do so many things. Most majority frequency characters. Majority frequency characters. Is it just outputting majority frequency characters? Is that it? Fuck, is my internet that bad? Okay, got it. It's not most occurring, but it's most different things that are there. Right. So first let's form frequencies. Okay, we have 26 characters. We are forming frequencies C minus A plus plus. So now we want, let's sort the frequencies. Okay, let's sort the frequencies from 0 comma frequency of uh, frequency comma frec plus 26. We have sorted the frequencies. So now we have to return majority frequency group, right? In any order. Okay, so even leave this thing. Okay, uh, appeared k times, right? So we will add all these characters, let's say. Okay, okay, we will add all the characters from all frequencies. So we are adding them to groups, let's say. Frequencies can be at max n plus 1, right? So I will add, so a plus I goes to this group, right? A plus I goes to this group. Now what do we want? We start with answer equals to 0. Okay, idx equals to minus 1, let's say. Okay, for groups, for I equals to 0, I less than or for k equals to 0, let's say k less than or equals to n k plus plus. So for groups, if groups of k dot size of greater than answer, then what should we do? Or equals to answer, because we have to take higher k, right? We have to take higher k. K is larger. If it equals, answer equals to groups of k dot size of idx equals to k. Now IDX will definitely be mm, 0 between 0 and k. Now we have to output that thing. String. Okay, let me just make it string. Return groups of k. We are done. I think we are good with this. So let's see if it works. So let's make it vector string. Okay. If that doesn't work, let's make a vector string. Frequency of. Now I don't know. So we spent quite amount of time, 5 minutes here. Wrong answer. How the fuck is our output this? For each character, why am I writing this? For all these things, okay, groups of size 0 took the answer. That was wrong. So we should have just ignored that 0. Size 0 I could have just ignored. Or I could have made this one. Fuck, that's a mistake. How should we avoid such mistakes? Let me read Q22. Okay. You're climbing a staircase with n plus 1 steps, numbered from 0 to n. You're also given one indexed array, cost of length n, where cost of I is the cost of step I. Okay, we have one indexed array, we have this 0 to n. Cost of what is cost of 0? Step 0, we don't know. For step I, you can jump only to step I plus 1, I plus 2, I plus 3. The cost of jumping from I to j is defined as follows. So it's just cost of j plus some weird thing. You start from step 0, cost equals to 0. Determine the minimum total cost required to. Okay, if we have minimum total cost to reach all steps, we can update that for all more steps, right? So let's just do that. So it's like a basic. So the whole bigger idea is if you can know minimum cost to reach I minus 1, I minus 2, you can brute force all possible ways to reach I plus 1, which is either reach, let's say this as I minus 1, I minus 2, I minus 3. If you can reach all these things, you can find for I. Either you come from I minus 1 or I minus 2 or I minus 2. So this is a shitty problem. It doesn't even have anything to think. It's just using this fact that that's it. So we have we call we let's we can call it F, array F. Okay. Okay. F of 0 equals to 0. Cost of 0 is also 0. For I equals to 1, I less than or equals to n, I plus plus. And then what should be written? We have to return minimum cost to reach step n, right? Minimum cost to reach step I. Reach I minus 1 and then reach this one. What would be the cost of that? So f of I is probably cost of I minus 1, and then you have to just take minimum of j minus I whole square. If if I minus 1 greater than or equals to 0, it is uh, so let me keep it 0. We want minimum cost, right? So let's keep it very big value. Let's keep it very bigger value than j minus I whole square. Let's keep it like 1e15. I think this value cost can be long. Cost can be very high, right? No, it can be very high. It can be very high. Let's keep it 10. Why? 3 square is at max. Let's keep it 1e9. Okay. I want to take minimum. If this happens, f of I equals to minimum of f of I comma I'm 1 plus cost of I minus 1. So if I minus 2 greater than or equals to 0, I minus 3 greater than or equals to 0, this will become 4, this will become 9, and then we are done. And then f of I equals to f of I plus equals to cost of I. So now we have to just return int answer equals to f of n. We have to return answer. I think we will be good with this. Uh, I don't know. It should be f. It should be I minus 1, right? Seems we are passing these things, right? So let's submit and see. I think it's just a simple brute force. It's called dynamic programming. We need not care why it's called dynamic programming. Let's try to read this problem. You're given a string S consisting of characters U, D, L, R, representing moves on an infinite 2D Cartesian grid. You're also given a Poisson integer K. You must choose and remove exactly one contiguous substring of length. See, guys, these problems are bad problems. Code Forces has nicer problems. Code Forces has problems that are like puzzles. Okay, these are not like puzzles. These are asking you to do random labor work. You're also given a positive integer k. You must choose and remove exactly one contiguous substring of length k. See labor work. You have to remove that. You have to remove this. From S, then start from coordinate 0, comma 0, and perform the remaining moves in order. Return an integer denoting the number of distinct final coordinates reachable. Okay, we want number of distinct final coordinates reachable. 138 have been accepted, it seems. So total sum of x, total sum of y, if we know, all we want is for many contiguous substring of length k. Okay, if you know total, if you know total x comma total y, once you remove some substring, it's just total x minus removed x, right? So number of distinct in this is exactly equals to number of distinct in this because there is a bijection between those sets. There is a bijection between this set and this set. So number of elements in this set is number of elements in this set. Because of that bijection, we can just count within this k thing. For that, we can use what? We can use the sliding window kind of thing, right? Int sx equals to 0 without e, sy equals to 0. Let's just go and do whatever happens with let me do this thing auto. Let me write a function. Okay, void move int x int y char c. If c equals to up, I'll do y plus plus. C equals to down, we'll do y minus minus. We have to access them as reference them, like we have to call by reference, not call by value. Is this x minus minus? I hope so. So now if we have this thing, I equals to 0, I less than n, I less than k. First let's collect k things, okay? And then we will find the next k things using the previous k things. We just have to add one new thing, remove one old thing. We have to move all of them here. If they're all identical, just move that one here now. Okay, now we have moved k times, right? Now I have to remove that. To remove that, what will I do? For int, these are the, we want to count distinct things, right? So let's just insert sx comma sy, okay? And now we have from I equals to k, I less than n, I plus plus. We know what to do. We have to add s of I, means move sx comma sy comma s of I. We are adding this. We have to remove s of I minus k. To remove this, what will I do? Maybe I'll just do dx dy uh, equals to 0 equals to 0. We have to remove this thing, right? So let's move in this direction. Move of dx dy comma s of I minus k. Now what will I do? I will subtract this direction. Sx minus equals to dx, sy minus equals to dy. And now I'll add our sx comma sx to the set, and then we will finally return. So this is just removing. I want to know the removal. To find its contribution, I'm using 0 0. We got its contribution. We're removing its contribution, and then we have our answer equals to s dot size of, and then we return answer. Should be right. Why am I getting errors all the fucking time? I don't know. Let's see if this passes. Okay, this is not that of a bad problem, but it is not that difficult too, I can say. How was that 5 points anyway? You're given an integer array nums. You want to maximize the alternating sum of nums, which is defined as the value obtained by adding elements at even and subtracting elements at odd. Okay, we have to maximize this, it seems. You're also given a 2D array swaps. For each pair in swaps, you're allowed to swap these elements. These swaps can be performed any number of times in any order. Return the maximum possible alternating sum of nums. What does a swap do? It connects those two things, right? It connects those two things. So those things are equivalent. Like if there is a swap, those things are equivalent. One existing here, or one existing here, one existing here doesn't make any sense. It doesn't make any difference because you can anyway change them. So even if you have three things, it's a set. So all the connected things, everything, every indices that can be connected with a swap, all of them can be anything. Okay, all of them can be anything. So now you have few groups where all of them can be anything. Okay, let's look at the groups. If there is one thing alone, it's group itself. Let's look at these groups. If it is alone, you cannot do anything. And within a group, you have few minus ones and you have few plus ones. What you should do within a group, you have to keep smaller elements in minus ones and bigger elements in plus ones to get maximum sum, right? Have to keep smaller elements in minus one, bigger elements in plus one. That's it. It's a simple problem. So one thing, you have to say swap. Okay, you can swap these two anytime. That means those two are together, right? Like it doesn't matter. You can swap them anytime. Now there is a third thing. These two are together. So if they are connecting to this, it's together. So if some things are together, they are together. And then we are good. We can do that. So if we maintain them, if we can find what are all together, this can be done using some simple graph algorithms like. So we have to go through each component. That's it, right? So these are simple things. Okay. So I will keep one visited array. This is a simple graph traversal algorithm. Let's say define n. N would be mm, equals to 0. So what this graph traversal algorithm does is it will try to visit everything. It will start with visiting something. Let's say this, we will have this. Okay, we have these swaps here, right? We will maintain this adjacency list, which is nothing but number of things that are connected to vertex v or adjacency list. So for every vertex v, we will try to see what all are connected to that directly. So how to make that? How to make that? Swaps. You know f of 0 and f of 1 are connected, right? So what you should do? X equals to f of 0, y equals to f of 1. So now x has y adjacent, y has x adjacent. So now you know everything that's adjacent, right? Now you know everything that's adjacent. Now you can think of a simple graph traversal algorithm which starts from one vertex and then it marks it as visited. And then it tries to go over everything that is adjacent to that. If we follow this, probably we will cover everything, right? You came here, you touched that, and then you're trying to touch other things. We are doing this recursively, so we will touch probably everything. But then we will not touch something that's been touched again because then we may go and fall in a loop. Okay. So we are done with this. So now, whenever we are touching this thing, what does that mean? We have its value in nums, right? We have its value in nums. Let's also add those values here. Vector int. So we have few indices, we have few groups, right? So let's just collect these values v. Vector int com. So let's just collect this component. So everything will be visited only once we are collecting the component. So now what should we do? We are again trying to go over all indices. Okay, we're trying to go over all indices. We're trying to go over all indices. I hope those are one based indexes. See, those are zero based indices, right? Swap 0 comma 2, swap 1 comma 2. So zero based indices. We have these indices. Even is plus 1, odd is minus 1. So what do we do? If this component has not been visited, I'll clear the component first to make sure it's empty, and then I'll do DFS of I. Now I have the component in component. So now what should I do? Now we have nums. Okay, we have nums. We have even and we have odd. So first let's vector int comp nums. Okay, for int v in comp nums dot pushback of nums of v. So I'm collecting the values. These are indices. We are collecting the values. After collecting the values, what should we do? We can rearrange these values as we like. And then we have some even indices, we have some odd indices. In odd indices, we have to keep negative value. In even indices, we have to keep positive value. So I'll sort this thing. I will also find count even equals to 0, count odd equals to 0. This is about indices. And v is our indices, right? V is our index. Ce plus equals to v remainder 2 equals to 0. So what should we do if v remainder 2 co plus plus else ce plus plus? So now what should we do? We have to sort. After sorting, what should we do? For smallest things, we have to subtract them because subtracting smaller, adding bigger is good, right? For int val comp nums, if if CO, if there is an odd thing, you have to subtract it, right? Answer minus equals to val CO minus minus. So after all the odd things are done, now we are left with even. So once all the odd things are gone, now we are left with even, and then we do answer plus equals to val CO. We need not do anything here. Okay, for everything else, we have to do that. So if I return answer, will it be correct? Okay, this is not that much of a bad problem, but then this is not that difficult to. It's just direct. Swap component, you can rearrange them as you like. Why won't it autocomplete? Little bit of autocomplete. So seems it's passing. If I submit 0212, 02 can be swapped, 12 can be swapped. Means we can get anything, right? According to my understanding, the answer is 2. But then how is it 4? Wait a minute. Should be 4, right? 3 plus 2 minus 1. What have happened? Okay, something is fishy. Something is wrong here. We are not getting the whole components. How? We are not getting the whole components 02, 1, 2. If not visited of you, if you haven't touched it, that one touch it, right? Sorry for that. Grave small mistake. But now we are good. Probably now we are good. We can submit this. You cannot solve problems when you're half asleep, I guess. So we are done. We're done for today. It's accepted. It's a small 30-minute video. But you have to see, thinking about this is not that difficult. Okay, now, see, you have to only focus on swap because that's what given to you. Don't think complex. What does a swap mean? Values doesn't matter. You can keep like this or like this. Now, let's say something else is connected. You can rearrange them as you like. Now you have a group. You can rearrange them as you like. So now you have some odd indices. So now you have some even indices. Odd indices has -1 weight. Even indices has +1 weight. You have to keep bigger things in even, smaller things in odd. Done. So this problem is also doable. It's not hard. Dick is harder. I'm ending the stream, guys. Bye.